Well, I am very, very excited to be able to have Dr. Christopher-Shade, who I feel is one of the foremost authorities, certainly in the country and possibly even the world, in mercury detoxification and detoxification in general, because as we have always said, is that detoxification is kind of a unified concept, and you're getting a lot of things out at the same time. So when we talk about mercury, we can't separate it from any of the other heavy metals, nor can we separate it from the toxic chemicals, because they're interconnection with the whole getting out process. And I really want to, I'm very, very impressed with the information you've been able to accumulate, Dr. Shade, and more impressed with the products that you have developed through that information and the testing that you have. So I'm very excited to hear from the horse's mouth some of this information. So please, thank you for helping us understand things, and take it away.
All right. Well, thank you very much, Dr. McClure. And you hit the nail right on the head. You can't separate all these different aspects of detox. You can't just have a mercury detox and not be affecting other metals and other chemicals at the same time. And a lot of those compartmentalizations of detoxification have led to sort of a mythology that is developed around detox. And if anything, what I want to do is provide more of a unified system for looking at the human detoxification system and how it works, and how to safely and effectively upregulate it to accomplish a broad-scale detoxification and restore health. And often when I give a talk, I call it looking inside the black box, because it was such a black box, the whole idea of how the detox system worked, the whole idea in the context of metals, of how to measure metals and what metal toxicity really meant was not very well understood. And so when we go through all of the slides, this is what we're going to be trying to do, is look deep inside the system and see how everything works. Now, before I go to the slides, I'd like just to let the practitioners know that this is our website. It's www.quicksilverscientific.com. Everything you really want to find is over in the clinical section, though there is some good information in the environmental section about mercury speciation and the different forms of mercury. But even when you are inside the clinical section, if you really want to get at the good information, you need to register to go into the members login. So if you don't have a login yet, go and register. You'll put some information in. That'll come into us. We'll assign you a password, and then you'll be able to get into this members login area. And inside the members login area is a lot of different educational material. There's product monographs about all of our major products, from IMD, our flagship product, to Clearway cofactors, which we'll talk specifically about. It's a phytonutrient antioxidant, to our liposomal antioxidant formulations. There's all of these different protocols, how to get people ready for amalgam removal, how to get them ready for detox, how to do the main detox, specific kidney protocols. We're constantly updating this and putting up new PowerPoint presentations. This is about our testing. There's an IOMT video, and we'll have the whole NIHA Integrated Health webinar series on there as well. So that is where you'll go for follow-up education. And now let's get into the webinar proper. Like I said, I call this looking inside the black box, understanding analytical approaches, diagnostic tools, and detoxification strategies. For mercury intoxication, I say, because that's really where I'm most highly trained, but as Mark pointed out in the beginning, detox is not just one metal, one component at once. And as you'll see as we go through here, we're going to be looking at the whole system and how to bring the whole system up, and within that system possibly targeting different aspects of it. But when we do our detox, you're going to remove a lot more than mercury. So often I lead off with this slide. When I first gave a talk in Chicago, Diane Meyer had me out for a seminar series she was doing out there, and I was out there with a lot of luminaries. Hal Huggins was with me, Lee Cowden was there, Boyd Haley was there, Meyer Eisenstein, and they all, they were all well known, and they all had a certain approach to looking at toxicity, a certain approach that they talked about. And I asked Diane what she wanted me to get across, and fortunately she got across what I really liked to get. She wanted me to talk about what I really like to talk about, and that's why does one person who's exposed to dental amalgam get really sick, and another person gets a little sick, and another person has no problem at all. And I dug up this slide that comes from a poisoning episode that happened in Iraq in 1972-73, where the villagers end up using seed that was supposed to be for the next year. There was a famine, so they used their replanting seed to make bread, and that wheat seed had been treated with methylmercury as a fungicide. And that was supposed to break down in the soil and then not affect the next year's growth. But they ate the treated seed, and they were highly, highly exposed to methylmercury, and it did at least give us a chance to look at some of the variations in what's called the half-life of mercury in a body. So the half-life is the time between the peak dose in the blood and half of the peak dose. They did this by measuring hair, which is a surrogate for blood. And what you saw was that over here on the left, this is biological half-life in days of methylmercury, and up here on the y-axis is the frequency, or the percent of the population that had that biological half-life. So you see about 5% of the people are very fast detoxifiers. They got rid of half of the peak dose of methylmercury in 40 days. Then you move up to another 10% that's running about 50 days. And then you get up into the 60 to 55 to 65 day period where the bulk of the people, maybe 40% of the people there. And then you start rolling back down the other arm of this histogram to the slow detoxifiers. So you have 10% of them out around 80 days and another 5% out around 100 days. So what you have here are the slow detoxifying aspects of the population. This is what we think of as a bell curve, and that's a normal distribution of stuff. So you can see, well, some people are fast detoxifiers, some people are slow detoxifiers. But now what about this big bar all the way out here? These people are 120 days for the half-life. That means they are ultra-slow detoxifiers, and it's not a small population. You're looking at about 12% of the population out here. So between these slow detoxifiers and the ultra-slow detoxifiers, you have the people who become the patients of those of us in the healthcare world who are dealing with toxicity. And you see they're a very specific bunch. And what are the parts of the equation that go into that? Well, there's two different parts. One is called the genetic polymorphism, and that would probably more likely be these people out here. And these are different in the genetic hand they were dealt in terms of detoxification. So at a genetic standpoint, they're not expressing their detoxification chemistry as well as other people are. Now, there are some questions about whether that's really genetic or what's called epigenetic. And in epigenetics, there you have the genes for, say, detoxification proteins, but you are unable to express them because of secondary modifications to the genes that may have come as a result of a toxic insult. The tricky thing with epigenetics is this may not have happened to you. It may have happened to your mother or even your grandmother. So there are multi-generational aspects of alterations in your genetic code, and these are just starting to be understood. And when you think about them in the light of something like dental amalgam, we're really getting into maybe the third generation of the population that's been really strongly exposed to dental amalgam. When I started this company, about 78% of the population had dental amalgam. And amalgam came around in the 1800s, but really came into strong use in the early 1900s. So there's a lot of things to think about in relations to genetics, epigenetics, and detox. But that's not the only aspect of impaired detoxification, because there's functional expression where you may have the genes, you may be able to access them, but your accessing of genes is not a steady thing that goes on through your life. You're not always expressing the same genes. There are environmental triggers that are telling you to express strongly or less strongly any different family of genes. This also goes into the epigenetic world when you look, and now I forgot the name of Bruce Lipton is the guy who was the great herald of epigenetics, and he, as a cell biologist, came to say that it was really the environment that was signaling the cell through the mechanism of the cell membrane how to express its genetics. So in the context of detoxification, we will see very clearly in the data that's been generated how inflammation and oxidative stress actually turn down the expression of your detoxification system. And if there's any one take-home message here to remember, now there'll be a lot of take-home messages, but this is a really good one to remember, and that's that inflammation, especially chronic inflammation, turns down your detoxification system, which opens you up to a retention of toxins. When Huggins first coined the term retention toxicity in 1973, he thought he was only talking about mercury. When I'd done all of this research, Hal Huggins was one of the first guys I presented this all to because he lives very close to me. And I remember the day when we were both looking at it, and I said to him, that means retention toxicity, and he finished the sentence, is not just mercury, it's all toxins. And inflammation is a big trigger for creating retention toxicity. Now, what are we going to talk about during this seminar series? First, I am going to go through a short overview of the whole seminar series. There's 5 main parts, and again, I'm going to give you an introduction to all 5 parts, and then we're going to go back to the beginning. And so we're going to talk about the key forms of mercury and the exposure routes, and that'll include what we see here is the elemental form of mercury, the metal itself, which has a liquid and gas form and is present as half of the makeup of dental amalgam. This then rusts to the inorganic mercury form, the salt formed by oxidation of elemental mercury, and this transformation from elemental to inorganic happens in both the oral cavity, where the inorganic mercury is swallowed, and it happens in the blood after the elemental mercury has been inhaled. You have methylmercury, which is an organomercurial that is found in fish and is formed in the environment and somewhat in the gut as well. And then you have ethylmercury, the synthetic organomercurial that was used as an antimicrobial in vaccines and other things like eye drops, other aspects of the healthcare system. Once we talk about those forms of mercury and really get the basics down as to what these forms are, because it's very important. You cannot talk about mercury just like it's one blanket subject. If you really want to understand it, you have to understand that some forms are good at getting in and other forms are good at exerting their toxicity, so you have to know the interchanges that take place. Then we're going to lead into talking about how the natural detoxification system works. We're going to talk about what I call the antioxidant detoxification protein repair supersystem. In this supersystem, we have at its core what we think of as antioxidants, things like vitamin C, vitamin E, CoQ10, vitamin A, lipoic acid, glutathione. I'll introduce you to thyroidoxin. But what we're going to see when we look at the supersystem is that these central antioxidants are really powerless without the enzyme systems that put them to use. For example, glutathione can only act as an antioxidant through the agency of glutathione peroxidase. It can, once it acts as an antioxidant, it's then oxidized and taken out of the pool of reduced antioxidants, and it is re-reduced by glutathione reductase, another enzyme. It is used for protein repair and reducing oxidized sulfur groups in the proteins through the agency of glutaredoxin. Through this agency, we find that cellular thiols become like a backup system to the glutathione, like a big bank of redox activity and redox potentiation. But it's only through this enzyme that works. We'll find that glutathione is powerless to detoxify you from mercury unless through the action of glutathionase transferase, the enzyme that links glutathione onto toxins. And then you can't get those toxins out of the body unless you've got this series of proteins, the multi-drug resistance proteins and the organic anion transport proteins. So it is really this big system that you need to induce and to nourish as you go through a detoxification. It's not just these central players. Then we're going to talk about the phases of detoxification as things move from what we knew before as phase 1 and phase 2 detoxification reactions. They move, and these things happen in the cells and move from the cells out of the cells through the agency of the phase 3 detoxification system, which is really little known and we're going to talk a lot about, but without which nothing is going to get out of the body. So in natural detoxification, we go from phase 1 to phase 2, phase 3 taking it out of the cell into the blood, another phase 3 transporter bringing it from the blood into the liver, another one dumping it from the liver into the small intestine, getting it then out of the body. And later when we talk about the dysregulation, we'll see how this falls apart. We're going to talk about the good news of detox. People ask me about detoxification of the brain, and indeed all of these mechanisms of detoxification are present in the brain and especially present at the capillaries at the blood-brain barrier. Here we'll see staining of capillaries of the blood-brain barrier showing in red phase 2 detoxification, in green phase 3, and in yellow where phase 2 and phase 3 are co-located, essentially creating an efflux pump that is designed to pump toxicity out of your brain. So it is up to us to activate and nurture that pump to remove the toxicity. Then we're going to move on to how the natural detoxification system gets altered, leading to biochemical stress. Now we see that same picture where everything was supposed to move out, but now inflammation has stopped the final door in the chain, leading to a buildup of phase 2 products, which leads to an inhibition of the phase 2 enzymes, but phase 1 keeps chugging along. And we'll look at this, and we look at this, and we see here we have a presentation of an inflamed intestine, a buildup of cellular and blood-borne toxins, and internal generation of oxidative stress due to overexpression of the phase 1 oxidation system. And this is really a picture of chronic disease today. Then we'll talk about how dental amalgam can be a central cause to that by irritating the small intestine, leading us to this backed up oxidative mechanism. Then we're going to talk about our testing, mercury speciation testing, and how we use that to look at mercury toxicity and how to monitor or how to direct and monitor our treatment. In our testing, this is we're the only testing lab in the world right now, clinical testing lab that is looking at mercury speciation. That meaning that we're separating organic and inorganic forms of mercury so that we can tell how much of this mercury is coming from fish consumption versus dental amalgam. And so we'll look at methylmercury from fish, we'll look at inorganic mercury that's coming from dental amalgam and from the breakdown of fish-based mercury. We will then look at actual functional expression of the body's detox system. For instance, in the terming of retention toxicity, Hal Huggins pinned it in 1973. He was looking at levels and he said, when people have dental amalgam, but they're only putting out small amounts of mercury in the urine, that is retention toxicity. Now, we didn't have all the tools to do this then, but now we can do it. Now we can compare the blood inorganic mercury to the urinary output of inorganic mercury, and when we see high blood, low urine, we see retention toxicity at a kidney point, the damming up of the mercury at the kidney. Now we know in the detox that we have to work on freeing up the kidney and getting higher output of mercury through the kidney before this person can really get these levels down. Analogously, we have blood methylmercury being compared to hair mercury. Hair mercury is a conduit only for methylmercury. Work going back about 10-15 years, Boyd Haley had looked at autistics and their release of mercury through the hair and found that the more severe the autism, the lower the amount of mercury in the hair in these children who were not able to process these organic forms of mercury. So the hair to blood ratio, blood methylmercury, shows us about how well the body is dealing with methylmercury. And then we're going to move into our detox system, the intestinal metal detox system, which we use to repair and amplify the body's natural detoxification system and safely remove mercury. We'll also talk then about the use of original Canton. This used to be called Canton marine plasma, and it has been used since the turn of the century, well, the turn of the 1900s for cleaning the terrain or the extracellular matrix, and we're going to show you also how to use it to modulate the autonomic nervous system, how to modulate back and forth between parasympathetic and sympathetic dominance so that you can control your detoxification. When we look at the requirements for mercury removal, biochemically you need effective phase 3 clearance. That's the movement through the transport doors out of the body, and this is going to include intestinal binding and elimination, what's thought of in a naturopathic context as intestinal binding. But that's only one aspect. Opening up these phase 3 doors is a much more important aspect. Then you're going to need effective GST activity. That's glutathione S-transferase, the phase 2 enzyme that is linking toxins to glutathione. This was what was referred to as mobilization, and things that we think of as mobilizers, things like garlic, are actually affecting phase 2 enzymes. And then the last thing you need is intracellular glutathione sufficiency. So we'll talk through our product system and how we develop that, and the parts that we use for that. IMD, our flagship product, intestinal metals detox. You'll also see this referred to as microsilica when it's sold through BioPure, Dietrich Klinghart's company. Dietrich Klinghart was the first guy to actively use IMD, and he still uses quite a bit of this. This is for opening up the phase 3 transporters and getting that movement out. And once the movement brings mercury or other metals into the gut, it will bind it then and prevent reabsorption. Dietrich calls this everything I ever wanted chlorella to be. Then we're going to talk about these phytonutrients, the Clearway Cleanse cofactors. This is a system of mostly polyphenolic antioxidants and a couple of other plant-based enzymes, as well as some B vitamins and some selenium and nattokinase for upregulating the activity of the phase 2 enzymes from inside the cell. This is a very exciting aspect of what we think of as antioxidant chemistry. This is much more powerful than just taking some vitamin C. This is getting your cells to turn on their production of intracellular antioxidants and the enzyme system that uses all of those antioxidants, upregulating it from inside the cell. And then we're going to talk about nanosphere nutrient delivery. How are we going to bring in the substrates for those enzymes to use once we've upregulated them? In our second step, we're going to bring glutathione in, we're going to bring vitamin C with our lipoic acid, and we're going to bring in EDTA with our lipoic acid for good delivery in for use by the cellular antioxidant enzymes. And then we're going to talk about how we're going to use the results of this testing to guide our treatments. And one of the things that I always want to get across, I wasn't very good about getting it across in the beginning, or maybe I really learned it more after we started, but there's 2 ways I tell people that they can fail with this system. And if they avoid these 2 ways, they will always have success. The 2 ways to fail are by starting too aggressively and getting too much movement too quickly, kind of burning the fingers of the patient, and they don't want to come back because they feel worse. The other way to fail is by not getting to a high enough dosage. If you don't get it to a high enough dosage, you don't hit these genetic triggers for upregulating the activity of the antioxidant and detoxification system from inside the cell. If you do not do that, you do not thoroughly purge the cell and reset the cell system. So in this schematic of dosage with time, you want to start at a low dosage, get the patient used to it, slowly ramp up over about 3 months to where you're going from base dosage or half base dosage up to 3 times dosage. And then you go into these periods of what I call intensives, these periods of 10 days on, 4 days off, maybe 3 of those to really set the cellular flush in action. And then you'll come back down to lower dosages, and you'll maintain those for another 3 to 9 months to maintain the momentum that you've developed over this early period. So in the beginning, starting low, especially with the real sick people, but then getting them up to high doses to really get the flush going. Other aspects we'll talk about pre-tox, which is getting people ready with drainage remedies, with homeopathic IMD, with ketone isotonic, intestinal normalization, probiotics, prebiotics, symbiotics. So now, back to the beginning of the game here. Let's go back in and talk more specifically about the key forms of mercury, make you a little bit more of a connoisseur of mercury exposure and mercury toxicity. Oh, how did we get to the end? That's an interesting one. Let me, there's always funny buttons to hit. All right, jump all the way up. Ba-boom. Okay. So, talking about the forms of mercury again, I said to run through them from the beginning. Elemental mercury is the metallic form. It has both a liquid and a gas form. As the term quicksilver, like Quicksilver Scientific, it really means water silver. And you look at the Japanese for mercury is suijin is water silver, hydrargyrum is water silver. That's that liquidy metal that we know. And just like any element, if there's a liquid there, there's also a gas form. So elemental mercury has a very high vapor pressure, meaning a lot of that liquid metallic mercury is moving off into a gas form. Even when you amalgamate that with silver, as in the case of a dental amalgam, there is still a very high vapor pressure that is very easily measurable that's coming off of there. Now, I'd said that the elemental mercury will oxidize to inorganic mercury. This is essentially a rusting reaction. This is the salt form of mercury. And contrary to many things you may have heard before, this is the most toxic form of mercury from a cellular perspective. From an epidemiological perspective, like if we poured it down your throat, it is not the most toxic because it doesn't get absorbed very well. Now, what it does do when it goes down your throat is it ulcerates your intestines if we gave you enough of it. Now, at the small amounts that you're swallowing all the time from your amalgam, what you could be creating there is a constant irritation, a chronic irritation of the gut. And remember, I told you that I'm going to get into why inflammation turns down detoxification reactions. So inorganic mercury is present in 2 ways. You're swallowing it out of the oral cavity where it's corroding off of your dental amalgams, and that's setting up this corrosion reaction potential in your gut. The other way that you're getting is you're inhaling the elemental mercury, and it's oxidizing to the salt form in your blood. Methylmercury, then formed by organomercurial synthesis. This is happening in the environment. It is also happening in your intestines. And ethylmercury, the synthetic organomercurial. Now, this is the picture I showed you in the beginning. Again, this is corroding in the mouth and you're swallowing it, or it is going off as a vapor and you're inhaling it. I'll just run through those since I kind of described them well already, and let's get into the path in. So how well do you absorb this vapor when it's coming off the teeth and into your lungs? You have an 80% uptake into the blood through the alveoli. At that point, the elemental mercury circulates through the body. They estimate it takes 1 to 3 or 4 passes before it runs into a reaction with catalase, and then it is oxidized from elemental mercury into inorganic mercury. It is as this form inorganic mercury that it starts to bind to membranes, starts to bind to enzymes, it starts to bind to cellular thiols, and exert its really toxic effect. Now, it's very important to remember at this point that elemental mercury, while it is still elemental mercury in the blood, it can cross the blood-brain barrier, it can cross the placental barrier. It can go virtually anywhere it wants to go through strict diffusion because it is small and neutral. Once it oxidizes to inorganic mercury, sorry, I keep hitting weird buttons here. Once it oxidizes to inorganic mercury, then it sticks to the tissues and is very slow to move out. So if it is present as elemental mercury in the brain and oxidizes there, then it sticks into the brain, and it takes a long, long time to come out of the brain. Now, once it's in the blood and it's circulating through the blood as inorganic mercury, it cannot cross back into the blood-brain barrier, and it crosses at a reduced rate into the placental barrier. But it does move out then, and it's moving out through the liver, the kidneys, and the intestines. And thus, these are the biggest places of deposition of inorganic mercury. And thus, nephrotoxicity, hepatotoxicity, and intestinal problems are probably the largest issues, physical issues that happen with mercury. But the neurotoxicity and the mental emotional aspect of mercury toxicity is one that's probably not recognized in a high enough rate. That's probably because everybody is crazy these days. But if you look at it very specifically, you will see a lot of mental emotional problems with inorganic mercury. So fish consumption, what do you have there? You have 95% uptake through the gut. Methylmercury is bound into the muscles of the fish, bound onto cysteine residues in the protein structure. That's making a methylmercury cysteine complex. Once you hydrolyze all the amino acids out of the protein, the methylmercury cysteine appears to your gut as methionine. It is a molecular mimic for methionine. So your L-neutral amino acid transporters take it up at a 95% efficiency. What also takes it up is your blood-brain barrier, thinking, oh good, methionine for the brain. Oh good, methionine for the liver. Oh good, methionine for the baby. Methylmercury here is less toxic than inorganic mercury to the cells, but its danger is its great ability to be taken up in the gut. And once it is taken into the body, it slowly breaks down into the inorganic mercury. So it's got, say, X amount of toxicity as methylmercury. It's got 5 to 10X times the toxicity as inorganic mercury. Vaccines, well, their uptake is pretty easy. You inject them into people, and they distribute everywhere that methylmercury does, but they break down into inorganic mercury much faster. So they have the ability to get into all the tissues very quickly, like methylmercury does, and they turn into inorganic mercury very, very quickly as well. Transport of mercury. So, just to review, elemental mercury, 80% uptake through the lungs, crosses the blood-brain barrier, diffuses into the tissues. Inorganic mercury, very poor uptake in the intestines, poor mobility, does not cross the blood-brain barrier. So that is not something that's really going in. That is an ultimate point of breakdown of the different forms of mercury. But like I said before, from the cellular perspective, it is the most toxic form. So how do you get it in? You get it in as elemental mercury, you get it in as methylmercury. Methylmercury, 95% uptake through the intestines, good mobility, crosses the blood-brain barrier. Ethylmercury, 100% absorption, good mobility, also crosses the blood-brain barrier. So all of these forms are coming in, and they're slowly breaking down into this form. These two forms have toxicity as they are, and more toxicity once they're broken all the way down. Transformation, elemental mercury can turn to inorganic, inorganic can turn to elemental, inorganic can turn to methylmercury in the intestines. There you're swallowing large amounts of inorganic mercury, corrosion product off of the amalgams, and it's slowly turning into methylmercury, which is nicely absorbed. So that's another route back into the body. Methylmercury can also break down into inorganic mercury, both in the tissues and in the intestines. When it breaks down in the intestines, that is a good thing, because then you can't reabsorb it in the intestines. When we talk about methylmercury absorption, we will talk about what's called enterohepatic circulation, where methylmercury is conjugated to glutathione, moved out through the bile, but then is reabsorbed once the glutathione is broken back down to cysteine. And ethylmercury breaks down to inorganic mercury. So what are the targets of the mercury forms? Well, the whole term "mad as a hatter" comes from the hatting factories. A lot of these were out in Connecticut, and these people used mercury nitrate as part of the felting procedure, and they tended to lick their fingers a lot, and it was kind of sweet, and they ended up with a lot of neurological things. You've got the Mad Hatter from Alice in Wonderland. Recently, we did a study with IAOMT dentists, and we found that the mental emotional symptom scores correlated better with the mercury exposure than did the physical symptom scores. So mental emotional issues are a really big deal, and central nervous system toxicity is a really big deal. I seem to be seeing a lot more people with a combination of mercury toxicity and neural Lyme, and I know out at NIHA you deal with a lot of that kind of an issue. The kidney then is probably the biggest physical source, not that the brain isn't physical, but the kidney nephrotoxicity has been described for decades as one of the main issues in mercury accumulation. The liver then is the second biggest issue. Now, if you look from a Chinese medical perspective, you'll very, very commonly see what they call deficient kidney, excess liver. So the adrenals have been blown out by all of this mercury exposure, and the liver is toxic and irritated by that. And that's one of the very telltale symptom of amalgam toxicity. The heart is a new one on the block. People have known for a long time about the study in Italy showing idiopathic dilative cardiomyopathy, where the myocardium of the heart has 20,000 times more mercury than myocardium of a normal patient. Nobody really understands why that was, and that was sort of a lone study. But now in the last decade, 9 out of 10 studies looking at fish consumption have shown mercury as a culprit, as a negative factor in heart disease, where the first study that was done on it didn't really see any problem, but they weren't able to effectively statistically remove the positive impact of the omega-3 oils from the negative impact of the mercury. So heart disease we will see expressed a lot, and that may be one of the great factors that puts mercury toxicity on the map. Now, anyone who deals with women and mercury toxicity will say, oh yeah, thyroid issues, we see them all the time. So glandular disruption from a combination of pituitary and thyroid dysregulation. Pituitary gets a whopping dose of mercury in it. It's right outside of the blood-brain barrier, and it has 3 or more times more mercury in it than the rest of the brain. So those are your main things that happen. Oh, I mentioned earlier the transgenerational dysfunction. One of the studies that I saw recently, it was actually done on amphibians, but you know, there's better research done on animals than there is on humans, because we don't really want to know what's happening in humans because there's too many commercial products that are causing mercury exposure. But when we look at animals, we can say, well, it's non-point source pollution, it's coal coming from China. And this particular study that just came out was looking at frogs, and what they showed was that if they took mother frogs from mercury exposed and non-mercury exposed areas, they both had tadpoles. They had a normal spread of children, but then in the next generation, the frogs from the mothers that had been previously exposed, when they re-exposed them to mercury, many, many more of them died than the non-exposed frogs. So we saw the mother in the first round of exposure was okay, but the second round of exposure was much more susceptible. Now, this is not what we typically see with toxicity, where areas will build up, they'll build up less susceptibility to build up a tolerance to it over time. Here with mercury, we're actually building an intolerance with it over time. Now again, think back to these multiple generations of amalgam exposed populations. What is the implication of this for our human population? Symptoms of heavy metal toxicity. I have this quote here: as heavy metals affect many organs and functions of the body, they elicit complaints and symptoms that are different from person to person and do not easily fit into the usual diagnostic categories. Therefore, they are often difficult to diagnose. And therein lies the biggest problem with mercury toxicity. What is your weakest link in your chain? That's where you're going to be hit, and that's why it's not obvious to mainstream medicine that there is a problem with that, with mercury toxicity. As we get better at finding better diagnostic criteria, this will change. I'm going to skip through some of these, but some of these you can go back to them. Symptoms of chronic mercury toxicity. It's important to realize that different people get hit in different systems. Some people come to me with all nervous system problems. Some people it's all immune problems. Sometimes it's skin and everything else is fine. Sometimes it's endocrine, or it's cardiovascular, it's gastrointestinal, and sometimes it's a mix of all these. So it's very important to make good use of symptom questionnaires and be able to identify where these patients are really getting hit. And immune dysregulation, I'll let you go back to this one as well, but basically you can go anywhere from immune suppression, where you're letting disease in, to overexpression of the immune system, and that's autoimmune diseases, or allergy type 4 hypersensitivity. This is what's associated with ELISA testing. Mental health, I had mentioned, is really a big one, and I really encourage people to think more about this and think about how to ask their patients about this and how to recognize this in their patients. One of the worst problems here is that there's a lot of paranoia that comes around mercury toxicity, and paranoia about what other people are thinking about your paranoia. You know, my father, who's a paranoid guy, likes to say, what was the joke? Oh, I like to go to the football games, but I hate when they get together in those huddles and start talking about me. And then he'll say, and just because I'm paranoid doesn't mean they're not talking about me. And that's becomes a problem in assessing the problems, because often they don't really want to tell you about these things. Depression and anxiety they'll often talk about, but some of the other aspects they won't. Really, a lot of this came clear to me when we started dealing with a mental health clinic up in Toronto, and this guy specialized in schizophrenia, and he sent me all of these tests to look at, and as a population, his patients had higher mercury than any other population of patients that I had dealt with. That induced me to look at glutathione and mental health, and indeed, there's a very well documented localized deficiency of glutathione in the brain of schizophrenics, which begs the question then, are they schizophrenics from birth, or did they become schizophrenic when they're exposed to enough toxins that they have an inadequate detox system for? So as that load built up in the brain, they start to express symptoms of what we call schizophrenia. Let's see, we got plenty of time here to dig deep into the heart of toxicity. So how is mercury exerting its toxic effect in the body? Well, there are two main things. One is inappropriate binding, and that's binding to enzymes, redox proteins, and membranes. And the other is oxidative damage and the related inflammation that comes as a result either of buildup of reactive oxygen species or inflammation that's coming as a downstream reactions from inappropriate binding, such as binding to membranes. And I'll talk about this in the next slide. So in inappropriate binding, everything that we're dealing with in mercury specifically and in metals in general has to do with thiol binding. Now, thiols are reduced sulfur groups. R being any generic group, say R was a generic amino acid, and then coming off that amino acid is an SH, the sulfur and the hydrogen along with it. This is the thiol group. And what happens here is that the mercury comes in and replaces the proton on this group, giving you now mercury-bound thiol. So if that was a cysteine, this would be a mercury-cysteine conjugate. If that was glutathione, that's a mercury-glutathione conjugate. If that was a membrane thiol, now you have mercury bound to the membrane. If this was a thiol on an enzyme, now you have mercury bound to the enzyme. Now, this is really important. Well, it's important in all of these things, but let's think about enzymes, because everybody's very into enzymes now. And what do enzymes do? But enzymes sort of anchor and catalyze whole hosts of different biochemical reactions in the body. They allow reactions to happen in the cells that normally wouldn't happen. If you had just taken the cell chemistry and you wanted the reaction to happen, it would never happen. It's not thermodynamically favorable. But the enzyme creates this little microenvironment where the reaction is favorable and it can happen at extremely fast rates. So enzymes are totally key to all the reactions that are sustaining us. Now, an enzyme is usually a big organic molecule, and at its core is a metal, a redox reactive metal that can trade electrons around to make these reactions go. And this could be a metal like zinc or copper or iron, and these are typically held in place by thiols like cysteines or iron sulfur proteins. Now, when zinc is being held by a thiol, the thiol has a good affinity for zinc, but it has more affinity for mercury. Now, how much more affinity do you think it has? Do you think 10 times more affinity for the mercury than the zinc? 20 times? 100 times? How about 1 billion times? That is not a crazy number I made up. That is 10 to the 9th. That is the difference in the binding constants between zinc and mercury for, say, a cysteine. And so if the mercury waltzes by an enzyme that's anchoring a zinc molecule, what's going to happen? Some or all of those cysteines are going to pop off of the zinc and bind to the mercury, and you're going to inactivate the enzymes. And in fact, then there is a whole host of different proteins called zinc finger proteins that are essential for your metabolism that are anchoring zincs in place, and the mercury is going to disrupt all of them. Now, when you get to something like a membrane, you have thiols on the membranes that are important to your redox chemistry. That's your distribution between reduced and oxidized species in your cellular milieu. And when mercury binds, there's a wonderful study that shows that when mercury binds to thiols on the cell membranes of the epithelium of the vascular system, there is a sequence of reactions that are catalyzed whereby your cell membranes actually destroy themselves. Well, they lyse themselves to throw off that mercury thiol group in the activity. Then they spell out a whole bunch of calcium. They catalyze inflammatory reactions, and in the downstream reactions, there's a shrinking of the actin, which is sort of the framework for the vasculature, and this pulls little pinholes in the vasculature then. Then you start leaking out proteins, and what do? You call in the spackling crew. You call in the crew to drop cholesterol into those little holes and plug them up. And now they're finding that really the origin of the buildup of plaque in the membranes is an oxidative reaction that is very strongly catalyzed by metals. So metals can cause the plaque buildup, and cholesterol is actually a protective mechanism. It is not the culprit. So these are various ways in which mercury can get in the way of our cellular chemistry. The other thing is to go after our core redox proteins, those being thioredoxin and glutathione. Thioredoxin is like a super nanobot of glutathione. It's like super glutathione. And in the coming years, you'll hear a lot more talk about thioredoxin. And I think I have a couple slides on that when we talk about the antioxidant system. So pathways out. How do you get mercury out of the body? Methylmercury is moved out through the liver and out through the bile into the intestines, whereas inorganic mercury is split roughly 50-50 between the liver and intestines and the kidneys. Now we're going to slip into talking about how the natural detoxification system works. So I talked about the antioxidant detoxification protein repair system in the beginning, and I'm very fond of this slide and this whole system because it just tells us so much about how we should be working with our system. And at the core of this, there are these antioxidants that we know of. And in the antioxidants, we've got what are called the exogenous antioxidants and endogenous antioxidants. So the exogenous antioxidants would be like vitamin C, vitamin E, vitamin A, lipoic acid. These are things we take from the outside. We eat them to boost our antioxidant reservoirs inside. And then in the endogenous antioxidants, these are really actually more potent towards changing your milieu. These are the ones that you make. This is glutathione, cysteine. Cysteine you don't make, but you regulate it internally. Superoxide dismutase you make. CoQ10 you make. And now lipoic acid you can take from the outside, and CoQ10 you can take from the outside, but you can also make them from the inside. So roughly you've got these exogenous and endogenous ones, but what are conspicuously absent from here? The plant compounds, things like oligomeric proanthocyanidins and other polyphenolic antioxidants. These are really different. We think of them as antioxidants, but they're not really antioxidants. The best way to think of these are actually as stimulators of the enzymes in your super system. So when you look at some of the different antioxidant players, it's important to realize that enzymes can shuttle. You have sources of reducing equivalents that are shuttled back and forth between these different elements of the antioxidant system. If we look in this diagram here from the outside moving inward, we have hydride equivalents. That's a hydrogen with an extra electron being pushed into the system. Here we have glutathione reductase bringing oxidized glutathione into reduced glutathione, and we can see that we can shuttle these different reducing equivalents into vitamin E, vitamin C, CoQ10, lipoic acid, and there are enzymes for doing all of these. The enzymes to shuttle between ascorbate and glutathione, between ascorbate and vitamin E, ascorbate and lipoic acid, glutathione and lipoic acid, thyrodoxine and lipoic acid. So it's more important from my view, to have the enzyme system active than it is to just be dumping in lots of antioxidants from the Antioxidant of the Month Club. It's important to be dumping those antioxidants in, but if you don't have the enzyme system up and revving, then there's not a lot you can do with those antioxidants. So now to look at the different wings of our super system, you have the antioxidant wing. You've got in there glutathione peroxidase, thyrodoxine peroxidase, peroxyredoxin 3 and 5, ascorbate peroxidase. And what these do is use your central antioxidants like glutathione peroxidase, using glutathione to quench peroxidation. Those could be hydrogen peroxides or it could be lipid peroxidation. Then we have the redoxins. These are responsible for protein repair. You've got thyrodoxine and glutaredoxin. They're going to use these reducing equivalents to repair oxidized elements of the protein sulfhydryl groups. And then we've got reductases. Say we've just used glutathione, glutaredoxin has just used glutathione to reduce some oxidized proteins. Then you're left with oxidized glutathione, and you want to bring that back into your central reduced glutathione pool, and you're going to use glutathione reductase. For thyrodoxine, you've got thyrodoxine reductase. For vitamin C, you have dehydroascorbate reductase. For lipoic acid, you have lipoamide dehydrogenase. So without these being active, you're going to run out of reduced equivalents in your central antioxidant pool. Now, thyrodoxine, I had mentioned it being like a super nanobot. It's a powerful free radical quencher and protein repair enzyme. It is required for RNA transcription. Without thyrodoxine, you cannot have your RNA go transcribe the signal from the DNA so that you can go and produce the proteins you need to produce. So that's pretty important. There, if you do, you may have the DNA to code for a certain set of proteins, say detoxification proteins, but if you don't have enough thyroredoxin, you can't reduce your RNA to go dock on and take that signal and go make that protein. They're also found to be very strongly neuroprotective. So is this one of the things that makes one person more susceptible to the neurotoxicity of mercury than another? We don't know, but we do want to find this out. And very, very importantly, they're more susceptible to oxidation by metals than the glutathione system is. And in fact, when they did a paper and they took the whole glutathione system and the whole thyrodoxin system, dumped mercury in both, and saw which of them kept on spinning, it was the glutathione system that could take the hit and keep going, but the thyrodoxin system could not. And in fact, apoptosis signaling kinase, which tells your cell it's time to die, is actually held in place by thyrodoxin. And once either enough oxidative activity or enough metals get past the glutathione to hit the thyrodoxin, that triggers apoptosis. And there's very strong interactions into the antioxidant web. In fact, type 2 diabetes is treated through high doses of lipoic acid in Germany, and I found a great paper showing how thyrodoxin and lipoic acid work together to reduce insulin polymers into insulin monomers, which are then much more active. So oxidative stress can create polymerization of the thiols on diabetes, or on insulin, resulting polymers of insulin, which are not very effective anymore. But also the insulin receptors have dithiols on them. So any metals or any oxidative stress can oxidize those so that they're not working anymore. So there's a great mechanism here where thyrodoxin and lipoic acid work together in the insulin system to reduce oxidized elements of the insulin system. Glutaredoxin, I love to look at this as redox buffering. The glutaredoxin system is kind of a transition between the thyrodoxin and the glutathione system. It's got elements of both, and what it does, you have way more reduced thiol groups in your protein, in the soluble proteins and the insoluble proteins of the cell than you have glutathione. And actually, when there's too much oxidative damage for the glutathione to quench, you actually can start using all of your different protein thiols. And it's the glutaredoxin system that catalyzes the use of those as antioxidants and then the regeneration of those afterwards. So it's a very important protein repair and redox buffering system. And also important to recognize is how the mitochondria have different a slightly different homology of all of the different redox and detoxification proteins. So there's a different thyrodoxin in the cytosol than there is in the mitochondria. There's a different glutathionase transferase in the mitochondria than there is in the cytosol. And there's a different glutaredoxin in the mitochondria than the cytosol. The mitochondria is a highly specialized area where all of your oxidative decomposition of food calories into energy takes place. And ironically, you actually keep this more highly reduced than you do the cytosol. And these specific proteins in here were made to be more susceptible or more resistant to oxidative damage in case you have runaway reactive oxygen species, but it turns out they're more susceptible to oxidative stress by metals. So in the mitochondria, these elements of your antioxidant and detox system are more easily hit by mercury, cadmium, and arsenic. This is probably a great clue into why many of the toxicity diseases like autism are mitochondrial diseases, and why so many people with mercury or metal toxicity have chronic fatigue and other mitochondrial problems. And in fact, in a paper by Jill James, she looked into whole cell extracts or mitochondrial extracts of cells in autistic versus non-autistic children, and she found the reduced pool of glutathione highly depleted in the whole cell extract. It was only 62% of the reduced glutathione pool of the non-autistic kids. But when she looked in the mitochondria, we found it even more depleted. Only 43% of the reduced glutathione pool of the non-autistic kids. So you're seeing the strong perpetuated oxidative damage at a mitochondrial level in autism. And I like to look at autism as an end member of these degenerative, inflammatory, oxidative, toxicity type conditions. So into the detoxification aspect of the super system, you've got glutathione S-transferase down here as your phase 2 mobilizer enzyme. Again, that's to conjugate mercury with glutathione. Then you've got the MRPs. These are the multi-drug resistance proteins. These take the mercury glutathione conjugates and shuttle them out of the cell. This whole system is for taking things that are generating free radical they're creating free radical generation in the cell and get them out of the cell. Get the irritant out of the cell. You'll find most of the research on this is done in journals like Carcinogenesis. Get the mutation promoters out of the cell. That's what these detox systems are for. So we look at glutathione as our central heavy metal defense. It is an antioxidant, a detoxification element, and a protein repair element, as we have just talked about. It is a thiolic tripeptide composed of glutamate, cysteine, and glycine. There's the glutamate, there's the glycine, and there's the business end of the gun with the sulfhydryl group, the cysteine. And they bind both methyl and inorganic mercury and escort these out of the body. As I said, there are many aspects. I'm not going to go through them because we just went through them all, but there are many aspects to the glutathione system. It is not enough to have glutathione. You have to be able to use it. In fact, given the choice, you want to be high in GST and low in glutathione. That is much better than low in glutathione. I'm sorry, that is much better than high in glutathione and low in GST. In fact, if you look in PubMed and you search glutathione levels in cancer, you will find nothing. If you search glutathione S-transferase in cancer, you will find hundreds of articles on this. So in the body, glutathione ionizes and turns to an anion. This then binds to the mercury. Here is mercuric diglutathione. This is one of the reasons mercuric mercury is more toxic than methyl mercury. It has two binding sites as opposed to methyl mercury glutathione. Methyl mercury is occupying one of the binding sites, so mercury can only exert its disruptive influence on one side. So when we come back next week, we are going to get into how the natural detoxification system gets altered, leading to biochemical stress. We'll go over the phases of detoxification and how those get altered, mostly from things like inflammation and how that stops up the whole system. So thank you very much for being here for this first round. And Mark, if you have any questions or comments to wrap up this first round, please go ahead.
Well, once again, Chris, thank you for your presentation. I know this was kind of an overview, but you're really laying out some tremendous groundwork here. And just to, once again reiterate is that what you're doing by teaching so well the natural detoxification system is just foundational for getting all the metals and chemicals and everything that our body needs to get the bad stuff out, laying that foundation to know how to go about doing that in the least disruptive way. So thank you, and we'll be looking forward to what you tell us next week.
Thank you very much, and I look forward to talking some more.